Welcome to this video. In this video, we continue the discussion of text analysis. In the previous video, we looked at the text analysis pipeline and we covered three first steps that are usually done to process text. Sentence segmentation, splitting the text into sentences, tokenization, which is splitting the sentences into words, as well as part-of-speech tagging, which is identifying the different roles that these words play in the text. Nouns, verbs, adjective, adverbs, and so on and so forth. This is kind of operating at the syntax of the text. In this lecture, we're going to talk a bit about the semantic, which is the meaning of the text. Obviously, this is a wide topic and it's not a resolved problem. It's still very hard to uncover the meaning that a piece of text conveys using computational methods, although the computational techniques are improving in terms of performance. We're going to talk specifically about two techniques that uncover different aspects of meaning in the text. We're going to talk about sentiment analysis, which is basically a technique that allows us to uncover whether the text conveys a positive or negative sentiment, as well as named entity extraction, which is classifying and grouping different words in the text to their general conceptual categories. In both of these techniques, we're going to rely on two packages, text blob and another package called Spacy. Once again, these two packages don't come pre-installed with Anaconda, so the very first step, if you don't have them, is to install them. I have provided code to install these packages, so for the very first time you need to uncomment and run these lines in order to install the package as well as the linguistic resources that it needs. I have all of these already installed, hence it was pretty quick. Again, once you install it, you don't need to run these commands anymore. Let's take a look at sentiment analysis. Now, sentiment analysis is a very widely used tool today. Today, it's very common for companies to probe the sentiment of end users, customers, especially in marketing applications or in digital campaigns application. You need to understand how people feel about your product, services, or a general topic. And there is plenty of text that reflect on people feeling, including on social media, for instance, including in news articles. So this is a very widely deployed technique. Now, under the hood, all of these sentiment analysis techniques are basically classification algorithms. They rely on the availability of some curated labeled text that maps certain text to positive or negative sentiment, and they train their model based on this text. We're not going to worry about what's under the hood for now. We're going just to apply these techniques. And TextBlob comes with a built-in sentiment analyzer, which does a decent job. It's not the best analyzer out there, but it does a pretty decent job in mainstream applications. Let's take a look at this piece of text, which is a song that I wrote for you. Now, I tried my best to combine positive and negative sentiments in this song. So you can read it and you can see that some of the sentences are positive, some of them are negative. Now in text blob, once we create the blob object on the text, we can access the sentiment, the overall sentiment of the text. And you can see here that text blob is giving us the sentiment in two dimensions. There's the polarity of the sentiment, which is the degree to which the sentiment is positive, versus being negative. So you can see that, and this ranges from -1 to 1, and you can see that, for instance, the sentiment, overall sentiment of this song is kind of positive. It's not super positive, but it's positive. The second dimension is the subjectivity of the sentiment, which is the degree to which the sentiment was expressed in a subjective manner. We can also repeat the process for each sentence. So if we go over each sentence in the blob, we can access the sentiment of the sentence, very much like we access the sentiment of the blob. Let us talk about named entity extraction. First, we need to install the package as well as the linguistic resources. Again, this is only needed for the first time. Once the installation is over, I can comment these lines or even delete the cell from the notebook. I don't need to run it anymore. Next, we need to import the package. Next, we're going to load the package. Once we load the package, the next step is to load the language model. There are two ways of loading the language model, either by calling the function load from Spacie, or by importing a package that corresponds to the language model and call the function load. Both of them do the same job. Once the language model is loaded, we can use it to process text. In this example, I have written a piece of text, that's a string, and then I'm creating a document by wrapping that string to the language model. Once the document is created, we can access some of the tools and techniques that Spacies provide by calling on some of the functions and attributes of this object. Now we're looking at named entities here. And the reason I created this document is that I wanted to include some named entities that we can all understand as things like places, person names, but those named entities are fictional, they don't exist in any dictionary. So obviously this is a much higher bar than saying, for instance, in United Kingdom, for instance, because the United Kingdom exists in dictionaries, for instance. Similarly, my name doesn't exist in a dictionary. Now, when we use Spacie to detect the named entities, we access the named entities by using the attribute .ents. Each entity has two dimensions here, the text itself and then the label of that entity. So in this example, we can see that it detected November 3rd, 2019 as a date entity, the Kingdom of Python as a general place entity, and my name as a person entity. And this is really impressive because, again, as I said, those two entities don't exist. The text of these entities is not something that exists in a dictionary. So it must be that the language model that Spacies provide is doing something more than looking up these words in a lexical resource. And indeed, Spacie is providing some cutting-edge models under the hood. And the reason I use this package is that this package is becoming used predominantly in advanced applications, NLP applications in Python. NLTK also provides its own named entity extraction tool, but it's not as advanced as that of Spacie. Spacie detects various kinds of entities. If I take a look at the documentation, it says that it can detect some of these built-in entity types, including things like person names, organizations, some of the places, general places like countries, cities, and states, other locations that are not general places, products, events, work of art, language, date, so on and so forth. And Spacie also provides ways to customize, what's under the hood. Let's take a look at a more involved example here. In this example, it's basically a news article from CNN from June 2nd, 2019. What I have done here, I basically created a document by wrapping the string to the natural language model, and then I'm looking at all of the entities here. Now you can see that for the first one is a mistake. That's the person name. Though it also doesn't provide the first name of that person. So it's kind of a mistake, and again, the model is not a silver bullet, but overall it did a good job. So you can see if you take a look at the named entity it extracted, all of them kind of make sense and they're accurate. And this is kind of one way to get at the semantics of this text. Because what we can do then, we can filter things like events, date, money, general places to get a more condensed summary and a more specific summary of what the text is about. This is something we will look at the exercise next.